Hello students, we will start the next topic. That is our next module. So evaluating the hypothesis. So till now we were just defining hypothesis and so many algorithms we have seen and so many concepts we have seen, right? Different types of learning algorithm. Now here, now this is also very important. Now when you are saying that you are learning something based on certain hypothesis, how to evaluate that hypothesis, right? Estimating our hypothesis, the accuracy, that is very important. So evaluating the hypothesis, so what do you mean by that? Now empirically, now evaluating a particular hypothesis, evaluating the accuracy, basically we are telling, if you are going to predict that you have built a model which predicts that a particular patient is suffering from COVID or not based on certain symptoms. Now what is the accuracy of your model? Whether it is able to predict 95% is correct that he is suffering from COVID based on certain the symptoms and what all the data set you are having, that is very important for us, right? Once you have built the model, it is just like saying that once you have developed entire software, you go for testing, right? Why you are testing? To say that whether it is correct or not. Similarly here, evaluating the accuracy and of a hypothesis is one of the fundamental criteria in any machine learning, right? Now here this model or this module, what you are going to see, it presents an introduction to the statistical method. Now what all the various statistical methods we are having for evaluating the accuracy of our hypothesis. Basically it focuses on three questions. What is the first question? Given the observed accuracy of a hypothesis over a limited sample of data, right? You have collected some limited samples of the data. Now for this limited sample of the data, let us say that your learning algorithm accuracy is 95%. How well does this estimate its accuracy over the additional examples? Today you have got 100 data points. Based on the 100 data points, your model is predicting 95%. Now tomorrow you collect another 50 data points. Now you have got 150 data points, or with that 50 data points, is your accuracy is same with 95% or it is increasing or decreasing? That is very important for us. How well does it estimate when you have got additional example? That is the first question. The second question is, given that one hypothesis overperforms another over some sample of data, how probable is that this hypothesis is more accurate in general, right? Overperform. So you have got some set of data points. Now for this data points, your model is predicting 95%, right, over some sample of data. Now how probable is that this hypothesis or the accuracy is same or increases in general, right? When a new instance is coming, is it good? Accuracy is improving. That's the second thing. The third point is when data is limited. You have got very limited data points. Now you are going to train on this particular limited data points. As we already know that when data points is very less, your accuracy of your training also is less only, because you don't have more data to learn. So when data is limited, now what is the best way to use this data to learn a hypothesis and estimate its accuracy? Like say for example, you have got 50 data points. In that 50 data points or 100 data points, you are saying 80% for learning and 20% for testing. Now 80% what you are using the learning, are you going to take all the first 80 records for learning, or randomly you are going to select? How you are trying to do? When you have got limited amount of data, what is the best way you can use this limited amount of data for learning a hypothesis as well as predicting the error or estimating the error in the hypothesis? So now limited samples of data might misinterpret the general distribution of the data. This is very clear. When you have got less amount of data, like say for example, you want to estimate the total pass percentage of machine learning in the entire university. Now when you want to predict that, now you have got very less amount of data of our college, around 5 or 10 students data you are having, the IA marks and all. Now when you try to model a system, now when the data is very less, there is the chances of misrepresentation. You don't know. So whether the data falls in a normal distribution or whether the data is skewed, right? So it is very difficult. So it misinterprets the general distribution of the data. With only less data, we cannot predict that entire population or entire data the same way they are behaving. So it misinterprets the general distribution of data, and estimating true accuracy for such sample can be misleading also. With this, for this particular small sample of data, you say 95%, but when your data is very huge, then the accuracy also will change, it will mislead, right? So, or say for example, there is a bias, right? So now you are just asking some information, and only I am taking the information from boys, I am not considering the girls. So then there is a bias, so it will mislead our accuracy also. That is a one important thing. Now statistical methods, what the various methods what you are going to see now, always together with some assumptions. Now we are having some assumptions, just like any machine learning algorithm or the learning we have studied, every learning we are using some assumption. Sometimes we have a data and we assume that it already behaves normal distribution and we start working. There will be, together with this assumption about the distribution of our data, allow one to bound the difference between observed accuracy over the sample of available data and the true accuracy over the entire distribution. Now, whatever the statistical methods we are going to consider, this method along with some assumptions, now we want to observe that for our sample data, what is the accuracy, and for the true data, the actual data, the when you are going in general from a small data, say for example, you are going to predict which party is going to win in the next election, general election. Now if you want to have a census, if you want to have a survey, you cannot consider each and every person in your entire India, right? What you are doing, you are taking some sample. For this sample, what is the accuracy you are going to have, and the true accuracy our entire distribution. So whether that is very important for us, right? So now why this is very important, why the finding the accuracy of our hypothesis is very important. So in many cases it is important to evaluate the performance of the learned hypothesis as precisely as possible, because the performance is very important for us. Today you said that you have built a machine learning model, and if your performance is not good, then what, right? It is no use, right? You need a mechanism, you need a yardstick, like to measure your performance, like how you have got examinations, why the examination is conducted, just to have, just to evaluate your performance, how much you have learned, how much you have studied. So it's one of the very important to evaluate the performance of our learned hypothesis, like say learning effectiveness of different medical treatment. So when you are going to take a disease of a cancer, so by giving chemotherapy, what is the effect? So by giving allopathy, what is the effect? By Ayurvedic treatment, what is the effect? Right? So inside the chemo again, or when you are going, you have got radiotherapy. Like this, effectiveness, you can learn the effectiveness of various methods what you are going to follow in the various treatments. Evaluating hypothesis, now it is an integral part of any learning mechanism. When you learn anything, you have to, someone has to evaluate. Today you say that you have learned this topic, there should be a way to evaluate that how much you have learned, what is the accuracy you are having. So it is an integral part of any machine learning algorithms. And estimating the accuracy of a hypothesis is relatively straightforward when the data is plentiful. Already we discussed, when you have got huge amount of data, when you have got more data, you learn more, and when you learn more, your accuracy is good, the errors are less. So when the data are more, however, when we must learn a hypothesis and estimates its future accuracy, right? This is the main thing. With a given data, survey data, what you are having, you learned, but the main thing is that when a new data comes, when a new patient comes, based on the symptoms, whether your model is trying to predict correctly or with more accuracy that he is suffering that particular disease, right? To estimate its future accuracy given only a limited set of data. So when you have got limited set of data, and when you want to predict when your accuracy wants to increase for a new data, now there are two important difficulties. So one is bias in the estimate. So there will be a bias in our estimation. So you know what is the meaning of bias. And the second one is the variance in the estimation. So variance in the sense that you have got some data points or data set. For this data set, your accuracy is good. Now you take another data point, again accuracy will be changing. Another data set, again accuracy changes. The accuracy, the variance is not same. So variance in the estimation is another important difficulties what we are going to find whenever you have got less amount of the data, right? So now when evaluating a learned hypothesis, we are most often interested in estimating the accuracy with which it classifies the future instance, right? This is what important for us. So when a new instance comes, when a future instance, when you are talking about a new cases or instance, are you going to predict properly? The accuracy is good, estimation is correct or not. At the same time, we would like to know the probable error in this accuracy estimation. Also, you see, when you are finding, when you say that 95% accurate, you are trying to predict, 5% error is there, right? Obviously, that the same time we are going to look into the probability of the errors also. If you reduce the error, then only your accuracy is going to increase. So one and the other is vice versa to this. If you are talking about accuracy, error is also there. If you want more accuracy, error has to be reduced. Now, so let us consider one particular problem setting so that we can try to go next level and try to understand one by one. Now there is some space, right? So we have got some set of sample space, and where from that sample space you are going to take the instances X. You know that. Let us take that set of all people over which various target functions may be defined. So we have got some instances. Each instance has got some attributes, you know it very well. So based on this attribute, some target value is there. So now if we take the set of all people as instances, and in this example, and what is our target? People who plan to purchase new skies this year. So skies is nothing but in icy locations they do skating, right? You need some type of an instrument to put under your feet so that you can skate and have a balance and all that. We generally call it as a sky. So now what is our target? Target is that people who plan to purchase this in this new year, right? When new year comes in the western countries, during that particular period of time there will be lot of snowfalls and people go for a vacation. And if they go for a vacation, some people will purchase this to enjoy it, some people may not purchase. So that is our target. Just like in our previous module we were telling whether the person can whether like to play tennis or not based on some attributes value. Similarly, we are going to define one particular problem here. Now we assume that different instances in X, right, number of people may be encountered with different frequencies. Right, when you start asking, when you take a survey, the people who came to that location, so we get different frequencies. So some people they purchase, some say that I'm not going to purchase, based on various attribute values, right? So a convenient way to model this is to assume that there is some unknown probability distribution. We assume initially, as we told, assumption is also important. Now we assume some distribution, unknown distribution D, that defines the probability of encountering each instance in X. Now we assume one unknown distribution. Based on that distribution, there is a probability of these instances which you are going to take, right? Now the learning task is to learn the target concept or the target function. What is the target function? The probability of people purchasing the materials or the skewing items, right? To learn the target concept by considering a space of possible hypotheses. So out of all possible hypotheses, how many are going to purchase? Now these training examples of target function F, now it are provided to the learner by a trainer. Who is a trainer? A trainer, he collects the data, he draws the data, each instances independently, you are going to collect some data based on certain survey or any other thing. So a trainer collects the data and he gives to your learning mechanism. Now, so it's that the machine starts learning. So now trainer is going to draw these instances independently according to a distribution D. What is this distribution D? We don't know, normal distribution or skewed or any other. We are assuming one probability unknown distribution. And who then? Now he forwards this instance X. So what the trainer does, he collects all these data points along with the target value f of x. So the target value should be there. Both of this is given to the learner. Now the learner starts learning, right? Now to illustrate this, consider the learning target function. What is the target function? People who plan to purchase new skies this year, right? Given a sample of training data collected by surveying people as they arrive at that resort. Now what the trainer does, he starts a survey. Where he does a survey, he go to that resort where the people are coming for vacation. Now there he asks questionnaires and collects some data points who are going to, or he asks everyone, the set of all, right? So first person he will ask, so are you going to purchase this sky? So for making or having or enjoying that snowy weather. That particular person along, when he is asking that, there are certain attributes, right? Then he will collect name of the person, age of the person, from which area he has come, how many times he have visited this place, last year also had he come to this particular visit, or this is the first time. Then he is going to ask the last target, are you going to purchase this sky? If he say yes, he may say yes or he may say no, right? That is what the target function. Who plan to purchase new skies this year? He may plan, he may say yes or he may no. Whatever is that, he will enter it. So like this he collects that particular data. Now in this case, the instance space X is the space of all the people who might be described by some attributes, like I said, told age, occupation, how many times they have come, etc. And he is going to collect. And that distribution D specifies for each person X. So for each person X, the probability that X will be encountered as the next person arriving at the sky resort. So now from that particular instance of each person X, based on the distribution, now you are going to find the probability. What is the probability that he is going to come to the sky resort? So now this entire thing, now we can write it as a function. How can we write the target function f? F is nothing but from set of all person X to target value either 0 or 1. So what is 1 here? He plans to purchase the skate, right? 0 means he don't want to purchase the skate. Now this is how you can classify each person according to whether or not they plan to purchase the skies this particular year. Now this is how we are going to define our problem. Now with this general setting of a problem, now we are interested in following two questions. Now here two questions are very important for us. The first one is, given a hypothesis yes, what is now hypothesis? What is our hypothesis? Yes, it is whether he purchases, whether he is planning to purchase this skies or not. That is our hypothesis. So given a hypothesis and certain set of data samples containing n examples drawn at random, right? You are going to ask randomly one by one persons who are entering according to some distribution D, what is the best estimate of accuracy H over future instance drawn from the same distribution. So today, based on 50 data points, now what all the data you have collected and how much percentage out of this 50 data point are going to plan to purchase and not, the probability. And when in future, when a new instance is been drawn from the same distribution, what is the accuracy, right? That is the first question what we want to understand. The second important question is, what is the probable error in this accuracy estimate? You already made an estimate with today you conducted one survey, right? With this particular survey you made an estimate that Okay, 40% are going to purchase this kite, 10% are not going to purchase this kite, or like say 60% are going to purchase, remaining 40% are not going to purchase. Now tomorrow with your estimation, you are saying that with this data now, what is the estimation you are going to make, accuracy you are, so 60/40, right? Now tomorrow when a new instance also comes, in tomorrow's data also 60% is going to purchase and 40% is not going to purchase, whether it is same. That is what is important for us. Now what is the probable error? Is it same or increasing or decreasing? Is there any error? What is the probable error in your accuracy estimation? So now these are the two important questions what we have to understand. So now to understand these things, so now we will be looking into this some of the very important terms, what is called as an sample error and what is called as a true error. So those things will be taking up in our next topic. So that is, we will be looking at the error. Now what do you mean by an error? So you know that we need to understand the accuracy. So if you want to calculate the accuracy, we are going to talk now about the error term. So if there is an error of 5%, means 95% accuracy is there. 95% accuracy means 5% error. What is you mean by the error? So what are the definition of an error? Now what are the two types of an errors are there? So now these things, now we will be trying to look in our next topic, right? So now this is just like an introduction. Now why this hypothesis, why estimating the accuracy of our hypothesis is very important for us, right? So in our next topic we will be looking into the what is the definition of the error, what are the type of errors we are going to consider, such that now we can start defining what is our hypothesis. We will be discussing shortly of these topics in our next section. Okay, thank you very much.